Good morning and welcome to Submarine Live. We're delighted to have you for this week where we'll be joining the Nekton First Descent mission. Now they're exploring the uncharted depths of the Indian Ocean around the Seychelles archipelago. We're based here at the Submarine HQ, the engineering team who make it possible to broadcast from the depths live to you. Over the next week, we've got a variety of sessions. This morning is a submarine Q&A, and we'll be connecting you to the expedition team to talk about science and life whilst exploring the depths of the ocean. Submarine Live is part of AXA XL Oceans Education, and I'm just going to have a look to see who we've got online this morning, the classes and schools we have with us. Great to see that we have schools from the UK, New Zealand, Colombia, Saudi Arabia and Ukraine. And I think before we head over and join the Nekton team, there are a few shout outs. So let me just get those up. And here we have the first shout out is to Marna Primary School in East London. Good morning. And their teacher, Ms. Hafford, would like to share, we would really like to learn about the oceans as the mysteries of the deep are inspiring and a million miles away from the busy motorway that our school lies on. We are all interested particularly in global warming and pollution as it really affects us in our day-to-day existence. Really looking forward to those questions coming from Marna Primary School. We've also got a shout out to Door Primary School. Hi to Year 5 FD, the best class at Door. Fantastic to have you with us. Hi also to 5M and 5MB at Lauderdale Junior School in Bethnal Green. And we've also got another shout out to Lauderdale from East London. Great to have an East London contingent with us today. So I'm just going to see whether we can get on the line Will West, who is head of...
Inmarsat has given us the satellites that we can do that. We partner with Oxford University and the scientists there, backed by the Seychelles government. On and on it goes. So yeah, none of it would be possible without all these different partners. And you may be looking at our vessel now. One of the challenges of a vessel like this is, this is usually used for the offshore industry, energy companies building wind farms, supplying wind farms and things. We've had to adapt it to turn it into a science ship and work with different teams and bring together a science team and a media team, a whole range of equipment that's never been put on a vessel like this. So that is a difficult undertaking. But we're here, we're succeeding. This is our 34th dive today that you're seeing. So far so good.
That, I mean, 34th dive, I mean, that's an amazing accomplishment for the team. Actually, I mean, how many dives are you hoping to do?
We'd set an initial target of 50 first descents, so 50 times we can descend into the deep ocean, the deep sea where people haven't been before. So we're looking to do a minimum of that, and I think we'll exceed that. Now maybe 100 would be nice to do. And each dive we undertake is gathering new scientific information, samples that we can take, or mapping the seabed, or all sorts of range of activities that we can do to help build our understanding of how this wonderful environment, our ocean, is changing.
Amazing. And just to put this in a sense of scale, I've got this question through from Door Primary School. And the point of reference, and I think probably the same for many of our primary students watching, is the Titanic, and that being at the bottom of the ocean. And naturally the bottom of the ocean varies, as we heard at the beginning, from a shallow beach at just a few meters all the way down to the sort of ocean depths. Could you put the Nekton First Descent mission in the context of the overall sort of ocean depth, if that's possible?
Yes, so we are scratching the surface, and at the top of the ocean, you've got what's called the sunlit zone. So where you got a little bit of sunlight, and then you go a little bit deeper, and you've got a little bit of sunlight, and that's called the twilight zone, and that's the focus of where we're really undertaking our research. And then you go deeper, from 1,000 meters down to 4,000 meters into the midnight zone, it's called, and 4,000 down to 6,000 meters is called, Jamie, what's it called?
What, from 4,000 to 6,000? Is it the, we've got to have the midnight?
The abyssal zone.
Abyssal, yes.
The abyssal zone. The
And
abyssal
I know
zone,
the
4
next
to
one.
6,000 meters. The next one, 6 to 11,000 meters is
The Hadal zone.
the Hadal zone, yes. So if you look, so we're just literally scratching the surface of the ocean. And it's interesting that right on the top is where we've got the majority of the largest quantity of animals. But when it comes to the types of different animals, i.e. what's called their diversity, the peak of that diversity, where we have more diversity, more different animals than anywhere else, is actually deeper down. It goes from about 1,000 to 3,000 meters. That's where we start to see more different animals than anywhere else. As you go a bit deeper, there's less food down there, so you have less different animals until you get into these really deep zones.
Amazing. And you were talking there about the twilight zone and the different sort of like levels of light that you find in the ocean. And you know, when you get down to the midnight sort of abyssal and Hadal, obviously no light. What's it like going down, sort of say to 200 meters? And I think we've got some footage, I think, of you exploring down at about 200, 250 meters. Does it feel like you're in the dark, in the depths?
Absolutely. I mean, as you descend down from the surface, it's as if you're going through a journey through different shades of blue. And those blues get darker and darker and darker. Because on the light spectrum, if you can imagine a rainbow, you have different lights, different colors. And actually the last color that gets absorbed is the blue color. And that's one of the main reasons our ocean is blue. It's also a kind of a mirror to the sky as well. So as you go down, it starts to descend, and then you lose light finally. There are tiny little particles of light down to 1,000 meters, but with our eyes, you can't see them. Once you're down to about 200, 250, well, depending on the time of day, you feel like you are enveloped in this inky darkness, this blackness. And you turn on the lights, and then all the colors come back. So you'll go into a coral that from distance looks like a black shade or something, and you go in close, you turn the lights on, and bosh, it comes to life in all its glory, whether it's reds or yellows and greens and all sorts of different colors that you find down there. So you just got to shine a bit of a light on it, and they pop up. One of the other amazing things is that a lot of animals in the deep, maybe about 90% of them, make their own light. And some of them, there's a fish called an anglerfish that has a light in front of its head. Which is for attracting prey, we think, or maybe it's just as a torch so they can have a look around and see things. I'm not a scientist. I'll defer to a scientist in the later, throughout the week, who can answer that more accurately, probably.
Perfect. And I mean, it's been amazing to have you with us. There's been several questions from schools really concerned about the ocean. As a final question, what can you share with schools about the importance of protecting the ocean, and B, what kind of future we can expect for the ocean?
Well, we all need to look after our ocean. If you like breathing, like we do, half of our air comes from the sea. So if everyone watching can take 2 deep breaths with me and Jamie. That second breath of air that you've just taken has been, the oxygen in there has come from the sea. So if you like breathing, we need to look after our sea. If you like eating, a lot of our food, our protein, our fish comes from the sea. We need to look after it. If you want a stable climate, stable weather, it's our ocean that gives us that stability. So we need to look after it as best we can. What we've seen recently is a lot of plastic, and we can relate to our impact because we can see our toothbrushes, our flip-flops, plastic bottles in the sea. That's come from us, people. This is going into the sea, and that's having an effect on all the animals that live there. And so there are lots of things we can do if we want to look after the sea and our ocean. And it starts at home. You know, just look at the things at home in the supermarket. and say, look, is this plastic? First question, is it made of plastic? Yes. Are we going to use that piece of plastic just once? Well, if so, then do we really need to use that? A plastic water bottle, for example, or a straw. There are other things you can use. You can go and get yourself a recyclable water bottle made of metal and keep filling that up. You don't need a straw. You can drink out of a glass, or get a straw made out of bamboo. Just think, ask questions. What is that? What's the impact that piece of plastic is going to have on this fish, this turtle, this tortoise, this whale, this shark? And then keep asking those questions, and then try and find out the solution. If you're in the supermarket, ask your mum or dad to go and ask the owner of the shop, why have you got all this plastic on? Because the more we talk about it, the more questions we ask, and enough of us doing that, it's going to have an effect. It's going to change. We can change. We can change the companies. We can change our governments. It comes down to us. Collectively, we can all make a difference. You and I, we both have young kids. They're asking these questions as well. They're saying, Daddy, why are we using that single plastic water bottle? Where's that plastic going? Is it going into the rubbish bin? Well, if so, why? Why can't we take it to the recycling? We can do these things. We just got to ask those questions and start getting on the front foot to try and work out what we can each do to make a difference.
Well, amazing, and thank you so much for that rallying cry, that incredibly important rallying cry to preserve and conserve the future of our oceans. And thank you so much, Oliver, for sparing the time to speak to these schools around the world and share some of the incredibly important work that the Nekton First Descent mission is doing in discovering these uncharted depths and bringing that to audiences across the world. So I think we're coming back to the studio here at Sonodyne HQ, and so until the next time, good luck and amazing to speak to you. Thanks so much, Oliver.
Thank you very much. Bye-bye for now.
Bye-bye for now. Well, thank you so much, especially to Lauderdale Junior School, Dore Primary School, Evelyn Day School, and to, I've got the last school coming up here, to Hafford, Miss Hafford's class at Marna Primary School. Amazing to have you with us. So this has been our first Submarine Q&A as part of Submarine Live as part of the AXA XL Oceans Education. And we're back in about 15 minutes for our first live investigation. And if you've been interested in how submersibles and submarines go up and down, then we'll be able to investigate some of the physics with that. Do stay tuned. We've got plenty more sessions coming over this week with Submarine Live. And if you're enjoying this, don't forget also that we have Arctic Live from the 1st to the 8th of May, and that is all running through Encounter EDU, encounteredu.com/live. Thank you for joining us, and it's goodbye for now. Goodbye.